So dear students, once again welcome, and here we are going to solve this problem. The problem statement is single rigid bar ABC. So you can see in the figure, this is A, B is here, C is here. Of L shape is loaded and supported as shown in the figure. Then what we have to do? What we have to find out? Find the support reactions. Okay. So support reactions here. The at C there is one roller. We are going to solve this solution. So firstly identify the supports. So at C there is a roller, and here suppose I am giving name here D. At D hinge support is there. Hinge support is there. Okay, and what about there is a this one, it is, this load is UVL, means UVL, uniformly varying load. Okay, and here it is supported, this structure, the bar is supported by this string. This is what? String. Okay, and this is what? This is pulley, and there is just some weight of 3 kilonewton. Okay, and it is in this question it is not mentioned the pulley is frictionless. It is not mentioned. Also it is not given the value of, suppose there is friction, so there should be value of coefficient of friction, some value. It is also not mentioned, means it is not given, this value is not given, and frictionless or frictionless or not mentioned, Okay, so in this case definitely you have to assume the frictionless surface of the pulley. So in that case what will be? There will be angle. We need to remove like this, in this way we have to show, and in tension form T, and the value will be here whatever the load is being suspended. Okay, so this 3 kilonewton. Okay, and angle is already given, this theta degree. So this we need to resolve the force. So what will be? This will be T cos theta degree, and this is T sin theta degree. Okay, and what about the UVL load? This load UVL, so how it is varying? So we can see here Okay, and what about the length where this load is acting? So it is 3 meter. And what about intensity? So this is the maximum intensity of the load, 2 kilonewton per meter. Okay, so firstly we have to get the load, means we have to convert, we have to convert this load into point load. Okay, so how to convert it? So take it, the total load is equal to area of the triangle. Okay, so what is the area of triangle here? 1 by 2, and this length 3 meter, and the maximum intensity 2. Okay, so you can see here unit of this is what? Unit of this meter, unit of this kilonewton per meter. Okay, so this and this will cancel by multiplying. So here what we are getting? 3 kilonewton we are getting. Now as we have converted this load into point load, for the calculation, means to satisfy the equilibrium conditions, so that we can get the reactions. Okay, so that's why the UVL, this is which kind of load? UVL. Okay, so it is converted into point load, and also to satisfy the criteria of summation of moment, we need to know about this load. This load is acting at which point in this triangle. Okay, so from here, and this is the point B, this is the A. So from here to here, and you can see the intensity, it starts from A to B, and this line is linear line. Okay, linearly it is varying. So intensity at A is 0, at B is high. So the center of gravity of this mass will act somewhere near B, not near A, because the intensities are less here. Okay, so it will lie somewhere, suppose here. Okay, what about its a distance? So how to take this one, this one? So from B it is L by 3 from B. Okay, what about from A? So obviously from A, let us do here. Okay, and this 3 meter is for whole length. Okay, what about this? This will be 2L by 3. So here we came to know where it is acting. So it is acting at L by 3, means from here to here it is 1 meter. So let us draw the FBD of this structure. So firstly what we have to do, this one, it is L structure. Okay, and this is subjected to T and it is equal to 3 kilo Newton and it inclined with 30 degree. Okay, and from this is the A, this is B, and from here to here it is 1 meter, and the total length is, it is 3 meter. Okay, so here we have to show the total load of this UVL. So it is what? It is 3 kilonewton. Okay, and at D there is a hinge, you can see at D there is a hinge. So support we have to remove in free body diagram. So suppose this is a vertical load and this I am taking VD, and this is the horizontal reaction, this I am taking HD. Okay, next there is a UDL also. Okay, let us discuss that. This is the UDL load. UDL means uniformly varying load, okay, and this also can be shown, like if you can find in many problems like this one, and its intensity is given here 1 kilonewton per meter, like that, equally this distance is okay. This should be equal, like let us do it, this one, okay. So here the intensity of the load is equal throughout the length of the beam. So either this can be, it can be shown in this form or in this form, both are same. So what about its a distance? So it is 6 meter. Okay, so what about the total load? It is area of the rectangle, and that is 6 into 1 with, suppose with unit 6 meter and 1 kilo Newton meter. So this cancels. Okay, so what we get, 6 kilonewton. Okay, so this distributed load is now converted into point load, and where it is acting, so definitely this is C this is D. So from here it is working at either C or D. So 6 by 2 means at the mid of the this span of the length is equal to 3 meter. Okay, so finally it is converted. This is converted DC into point load, and it is 6 kilonewton, and from here to here it is 3 meter 3 meter. Okay, so coming to this FDP FBD, this FBD. Okay, so from D to C, let us increase this length. D to C, and the total length is here 6 meter. So from here to here at 3 meter 6 kilonewton load is acting from here to here, and it is 3 meter. Okay, and at C there is also roller support. So roller support is replaced by the reaction acting vertically upward, RC. So in this way we have shown the free body diagram of the L-shaped structure. Okay, this is done. FBD is done. Okay, now what we have to do? We have to find out of the support reactions. Means what we have to find out? We have to find out HD is equal to what, VD is equal to what, RC is equal to what. Okay, so from where we can get the value easily? Suppose Fx is equal to 0, because there are only two horizontal forces acting in this structure. So let us apply this so that easily we can get the answer of these, and we feel like, yeah, something we have achieved. Okay, that is required for the motivation. So this one, T is inclined by 30 degree, so, and direction is positive, that's why T, and inclined with horizontal axis, that's why cos 30. And what about, okay, there are three forces. This is also 3 kilonewton, means UVL, uniformly varying load, is now converted into point load, and a direction is here in the negative direction. Three and plus HD is equal to 0, and T is equal to what? T is equal to 3. So from here we can get HD is equal to 0.4. Okay, and it is coming in positive direction, means our assumption, this one HD, the direction is correct. Okay, so HD we got. Now what about, suppose we apply the Fy, then what we are getting? this equilibrium condition we are going to satisfy. So firstly the VD plus RC, okay, we are coming from at C and at D, in between -6, this one we are taking, so it's a C in negative, sorry, it's a -6 in negative direction. What about, yeah, positive T and sine 30 degree is equal to 0. Okay, so however we have started, means we are going to satisfy the equilibrium condition, means acting forces in y directions, but there are two unknowns, this one VD and RC. T is already given, it's 3. So here we need to stop, we cannot proceed because two unknowns are there. Okay, so that's why we should know about either VD and RC. So this criteria already we have applied, this criteria summation of Fy we have already applied. So what is the rest, what is remaining? So here if you see, the remaining is, suppose this condition summation of moment is equal to 0. Okay, and let us take the moment about MD or the moment about any point you can take MC, but remember the point, means a moment about the point, we have to select the moment about which point. Okay, so answer of this which point, where more forces are acting. Okay, because there will be, means no distance from that perpendicular distance working at suppose at D. Okay, so at D how many forces are acting? So HD, VD, two forces are acting. Okay, and what about another point at, like at, this is at D, na? At D, at C only RC is working. Okay, so we have to select this one, at least two forces are acting. और भी ऐसा कोई भी पॉइंट नहीं है जहाँ पे दो फोर्स एक्ट कर रहे हैं. ठीक है, तो कैलकुलेशन बचाने के लिए, so that we can save our time, so it is a less expensive, okay, computationally. That's why we have to take moment about MD is equal to 0, and let us take the direction, this positive we are taking. Okay, so what will be RC? So here D के about ले रहे हैं हम, we are taking moment about D, this is the D and this is the RC. So RC will try to RC will try to RC will try to rotate the beam the anti-clockwise. Okay, anti-clockwise, this one. So that's why we need to take RC with minus sign, RC, and from D, this distance, the perpendicular distance, we have to take. This distance is how much? 6 meter. So it is multiplied by 6. Okay, and then this is done. What about 6? So 6, that is acting downward, means it will try to rotate the beam clockwise. So 6 and into multiplied by this distance, this distance from here to here, it is 3. So 3. So this is also done, 6 kilonewton. Okay, what about this 3 kilonewton? So the distance will be from here, from D to it will be this one, 1 meter, and it will try to rotate the clockwise. So 3 multiplied by 1. Okay, and one more force, the tension is there, so it will this one and this one, sorry, yeah, so this is what? T cos 30, it is T sin 30. Okay, so this one, the horizontal component we have to consider, and it is clockwise. So clockwise T cos 30, and what about the distance? So this 3 meter from B to A distance, it is 3 meter. What about the vertical component? And it will also try to rotate the beam in the clockwise. So T cosine theta, T sin theta into what? Okay, so into what means from here, from B to D distance, and it is given 3 meter. So we need to multiply with 3 and we have to equate with 0. Okay, so there is in this only one unknown is there, that is RC, and T is already known, it is given in the question, T is equal to 3 kilonewton. So this RC can be, after solving this, what we get? RC is equal to, we get 4.55 kilonewton. Okay, and what else is remaining? So from this equation, RC, this equation, the RC is equal to 4.55. okay, then VD we can get, and VD is equal to what we get? 0.0 5 kilonewton. Okay, so our answers HD is equal to HD is equal to what we got. HD 0. This one 0.4 kilonewton, and VD it is 0.05 kilonewton, and RC it is 4.55 kilonewton. Okay, so dear students, after getting result in this way we have to write, okay, so that all the answers can be written at the same place, okay, in this way. So this is our answer. So what we did here, however, this beam looks like very complex because there are number of things, means it is distributed, means it is loaded, this beam is loaded by this one, the uniformly UVL, uniformly varying load, and uniformly distributed load, and there are point load is also this one inclined, not point load, this inclined load, okay, due to string, and after replacing the support reactions, then definitely the point loads. Okay, so what is our approach? We have to convert either UVL or UDL. We have to convert into point loads. Okay, and then we need to draw the FBD after removing the support reactions, and then we have to satisfy all the equilibrium conditions, and it is which type of system? So definitely it is the coplanar non concurrent force system. Okay, that's why all three equilibrium conditions we need to satisfy: this one, and summation of m is equal to 0. ठीक है, सो हमने यही किए, आप भी कर सकते हैं. ओके, थैंक यू.